Okay, this is 3.5, parallel lines and triangles. So we're going to have a big idea here, a big theorem that's used quite a bit in geometry. It's the idea that if in any triangle, doesn't matter what size triangle, obtuse, acute, right? If you add up the three angles inside the triangle, they will always add up to 180 degrees. We'll go ahead and prove this. So as you're taking notes here, you can write this proof down. So we have a picture with what's called an auxiliary line in red here. The auxiliary line is just a helper line. It's going to be a way that we're going to prove this theorem, the fact that the three angles in a triangle add up to 180. So we're given that we have triangle ABC with auxiliary line PR. We're going to prove that measure of angle A plus measure of angle 2 plus measure of angle C equals 180 degrees. We're also going to state that our auxiliary line PR is parallel to AC because of a postulate that says through any single point not on a line, there's one and only one line parallel to the given line. So we can do that, and that's what we're doing right here. So I'm going to do this as a statement and reason proof here. Statements here, reasons here, starting with triangle ABC, and you could write in there with auxiliary line PR parallel to AC. All right, so that's the given. All right, number 2. What we want to do is associate angles 1 and 3 with other angles in the triangle, and then associate angles 1, 2, and 3 with those three angles inside the triangle. So 1, 2, and 3 would clearly add up to equal 180 degrees because they form that red line there. So we have measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180. So that's our statement. The reason for that is it's not a linear pair because there's 3 of them, but those 3 angles make a line. So you could say they form a line. Right? They form a line. Step number 3. Here's where we're going to tie in angles 1 and angles 3 with angles A and C. So I got angle 1 is congruent to angle A. I'll tell you why in just a minute. Angle 1 is congruent to angle A. Maybe you see it. Pause for a minute and just kind of look at that. What kind of angles are 1 and A? That's right, they're alternate interior angles. So if two lines, PR and AC, are parallel, as it says in the given, then angle 1 and A are congruent because of the alternate interior angles theorem. So the other set of angles that are congruent to each other are angles 3 and C. So we'll write angle 3 is congruent to angle C. I'm writing both of these statements as statement 3 because they have the same reason. It's the alternate interior angles theorem. Right? And then step 4 here is going to be a substitution process. I am going to swap for angle 1, I'm going to put in angle A, and for angle 3, I'm going to put in angle C. So here, and angle A is going to go in over on angle 1. So it'll look like this. Measure of angle A plus measure of angle 2 plus measure of angle C has to equal 180 degrees. And that's just a simple substitution. And that is the proof of the triangle sum theorem that says the three angles in a triangle, here, here, and here, no matter what the triangle is, what size it is, will always add up to 180. So as we've been doing all along, is once we get a theorem, we use the theorem to solve problems for missing angles, and then also solve some algebraic problems that use the same theorem. So example 1, we're finding the angle measures. We're given 2 out of 3 of them. These 2, 42 and 55, add up to 97, and then I'm going to just take 180 minus 97 to get my other angle, which happens to be 83 degrees. So I know that x here is 83 3 degrees so that the three angles, 83, 42, and 55, add up to 180. If you're given algebraic expressions instead of actual numeric values, we still know the fact that the three angles I've circled have to add up to 180. So I have x plus 2x plus 90 have to equal 180. So 3x plus 90 equals 180. Subtract 90 over 3x equals 90. Divide by 3, x equals 30. So this is actually a special right triangle. We'll learn more about this later. I've got a 30-degree angle here. 2 times 30 is 60. That's a 30, 60, 90 triangle. So you may be asked to set up and solve an algebra equation using that theorem. All right, the second theorem for this unit is the exterior angle theorem. I'm going to show you what an exterior angle is. This is an exterior angle. It's outside of the triangle. And it actually is equal to the sum of the two non-adjacent. Adjacent means not right next to. It's not this one, not that one. So non-adjacent. So it's equal to the sum of the two non-adjacent angles. So we're going to use that theorem to set up and solve an algebra equation. So 2x plus 10, the exterior angle, is equal to the two remote angles, they call them, or non-adjacent interior angles. They're also called remote because they're far away from the exterior angle. So 65 plus x. And we just got to solve this thing. I'm going to subtract x from each side. X plus 10 equals 65. And then subtract 10 over, and x equals 55. And then read the problem again. It says find the measure of the exterior angle. Okay, so that is 2 times 55 plus 10. 110 plus 10 is 120 degrees. It's 120 degrees. So once again, if you need to, pause the video, finish copying that down. I'm going to go ahead and move on. All right, so we've got this picture here. This is the picture we had in the beginning. We're told that AB is perpendicular to BC. So AB is perpendicular to BC. That means it makes a right angle right here, even if it doesn't look like it. Just pretend. We've got 120-degree angle down by A. We're told that these lines are parallel. Find the missing angles. We've got a 90 right here. If that's 120 there, this is 60 because they are a linear pair. And then angle 1 has to be 60 because alternate interior angles are congruent. I've got in the triangle a 60 and a 90, which add up to 150, leaving 30 degrees for angle 3, so that the three circled angles, according to the Triangle Sum Theorem, must add up to 180. All right, I want to talk about one of the homework problems you're going to run into. Actually, 22 and 24 you're going to do. We're going to pick one of them to do here, just to show you the setup for it. Let's look at number 22. It says the ratio of the angle measures of the acute angles in a right triangle is 1 to 2. Here's what that means. We actually saw an example of this in the first problem. Let me go back to it here. The first example, 1b. This is an example of that. We've got the two acute angles in a 1 to 2 ratio. It doesn't mean that they are 1 degrees and 2 degrees. It means that one of the angles is twice the other one in the triangle, and they still have to add up to 180. So that was an example of a problem like that. So this picture would work perfect for this homework problem right here. We could draw a right triangle, and we'd have a 90 here, and we'd have a 1x here, and a 2x here, and then you can solve it from there. It's just like the problem we just did. What if the measures of one angle of a triangle is 108? So the measure of one angle is 108, so that gives me an obtuse triangle, so maybe something like this. So it's a 108 here. And then it says the measure of the other two angles are in a ratio of 1 to 5. So that would mean, this is a little deceiving, but that would mean that one of them is 1x and the other one is 5x. And the sum of those three numbers or expressions has to equal 180. So I'm hoping those pictures will help you on those problems. I'll let you try the proof. 26 is a proof that's assigned. I'd like you to try that first, and we'll talk about it in class if you have questions on it. All right, thanks for watching.